Good morning, everyone, or good afternoon, actually. This lesson will have gone up right after our meeting today, our Zoom meeting, and hopefully you're all doing well, you're all healthy, and hopefully a lot of you joined us today for our meeting. Okay, I'm sure we'll talk about it during the meeting, but basically we're recording the lessons because it's easier for you to access these recordings and not have to be available using technology at a certain time. So we'll be posting these, and then I'll be available if you have any questions or concerns or just want to chat. All right. And with notice, I'll be available via Zoom or Google Meet on our classroom page. All right. So today we're going to talk about temperature and climate at the equator. And then we'll just review a few concepts that we've gone over in our past meetings or recordings. All right, so we talked about differential heating, global differential heating, and differential heating of land versus water. All right, global differential heating in a nutshell or quickly. Around where the earth is more flat than curved, you have concentrated rays of sun that heat up the earth way more than they do in where the earth curves around the northern and southern poles. Right, so as the earth curves, the sun's rays are dissipated versus concentrated. Right, they're concentrated around the equator, so it's hotter, and they're dissipated as you go up north or down south because the earth curves. All right, so that's differential heating globally. And then the differential heating, the difference in heating between land and water is that land heats up and cools down much faster than water. So during the day, the land is very hot and the water is just warming up, so it's cooler. And so over the ocean, you have a cool air mass compared to over the land that is hot. Okay, so the hot air, because it's hot, the molecules of air move away from each other. They have a lot of energy, they rise. And the cool air, because it's cold, it has less energy. It's being pulled down by gravity, so it stays down here. And because there's a difference in pressure, okay, the hot air causes an area of low pressure. The cool air causes an area of high pressure. The high pressure air will take the place of the low pressure air, and therefore you have sea breeze. And then this same process occurs on a global level with the land masses and oceans around the world, right? So eventually we'll learn about all of the different wind patterns and climate zones across the earth. But today we'll talk about how there's rising warm air, descending cold air, and then kind of like how it goes back and forth between rising and descending across the latitudes. Today we're going to focus on the equator, right? Very quickly. The equator is at 0 degrees latitude. It's the middle of the earth. And that's where, again, like we talked about before, the sun's solar energy is most concentrated at the equator. So what that creates is an area that's really, really hot, right? And because it's hot, where there is a landmass, the warm air over the landmass rises. And where there are oceans, the water is also warmed. And as it's warmed, it evaporates. And so you have a lot of condensation or a lot of creation of moisture in the air, which results in clouds. And these clouds move over the land masses, and there's a lot of rain here. So it's an area that's hot and humid with a lot of rain. And these areas are basically, most of the equator is tropical, right? Areas, land masses surrounding the equator are tropical because the equator, around the equator is warm, and you have a lot of clouds, a lot of rain, a lot of humidity. Okay, another thing that helps this climate are the trade winds. The trade winds that come down from 60 degrees latitude, which is right above, actually, sorry, 30 degrees latitude, which is right above zero, the next major latitude line. And in the northern hemisphere, it's in a clockwise fashion that the winds come down, go towards the west, and in the southern hemisphere, it's counterclockwise. Winds come up from 30 degrees and also go west. Okay, and there's a connection here between uh, the direction that these winds go, which is west, and the name of the winds, which is called trade winds. All right. Just very quickly, traders used these winds to explore, to go from the old world to the new world, and therefore they were called trade winds because a lot of trading and exploring happened because of these winds across the seas of the world. All right, so we just have a few questions um, this lesson. There's 5 questions. What does air do at the equator? You can see in this picture that looks like warm air rises. First of all, it heats up and then it rises. What does the air carry with it when it rises at the equator? Looks like moisture resulting in clouds. What type of climate exists at most of the land masses on the equator? I'll leave that up to you. It's hot, it's humid, lots of rain, and we call that something. What latitude is the equator? That's an easy one. We talked about it. It's not 30 or 60 or 90. It's the one that's the center. Okay, and what is the name of the wind pattern? It's right there in the picture, and I'll let you answer that. All right, so if you have any questions, as always, please comment or email me, and we will clarify anything that is confusing. All right, thank you, and talk to you soon.